Hello learners, this is Habeeba with Excelwithme. If you like the video, please do like, share, subscribe and comment below. Let's start today's class, that is research methodology paper, topic tests of significance, non-parametric tests and data analysis. Under that subtopic, first subtopic, that is concept and use of standard error, testing the significance of the statistical measures, mean and other statistics. Now let's start with the concept of standard error first. It is a mathematical tool used in statistics to measure variability. It enables one to arrive at one estimation of what the standard deviation of a given sample is. When we take any research problem, we have to give the data treatment. That is, whatever observations we have done, maybe questionnaires we have collected, we have to turn them into data that is to be calculated. First we find out the mean and then standard deviation. After that, whatever we have calculation done, it is we do take the estimation of what the standard deviation of a given sample is. Now it is commonly known by its abbreviated form, that is SE, that is standard error. Now, standard error is used to estimate the efficiency, accuracy and consistency of a sample. In other words, it measures how precisely a sampling distribution represents a population, obviously. Now, it can be applied in statistics and economics. It is especially useful in the field of econometrics, where researchers use it in performing regression analysis and hypothesis testing. Even in education also we use all these techniques here. It is also used in inferential statistics, where it forms the basis for the construction of the confidence intervals. Now, some commonly used measures in the field of statistics include standard error of the mean, that is SEM, standard error of the variance, then standard error of the median, standard error of a regression coefficient. Now, what is the formula for calculating the standard error of the mean? Let's see here, SEM, that is calculated using the formula standard deviation of the mean equal to standard deviation divided by square root of n. Now, where S is the population standard deviation and sample size, that is the number of observations in the sample. In a situation where statisticians are ignorant of the population standard deviation, they use the sample standard deviation as the closest replacement. That is, SEM can then be calculated using the following formula. One of the primary assumptions here is that observations in the sample are statistically independent. That is, SEM equal to S divided by square root of n, where S is sample standard deviation, n sample size, that is number of observation. Now, use of standard error here: when a sample of observations is extracted from a population and the sample mean is calculated, it serves as an estimate of the population mean. Almost certainly the sample mean will vary from the actual population mean. It will aid the statistician's research to identify the extent of the variation. It is where the standard error of the mean comes into play. When several random samples are extracted from a population, the standard error of the mean is essentially the standard deviation of different sample means from the population mean. However, multiple samples may not always be available to the statistician. Fortunately, the standard error of the mean can be calculated from a single sample itself. It is calculated by dividing the standard deviation. Just now we have seen the formula of the observations in the sample by the square root of the sample size. Now, testing the significance of statistical measures, that mean and other statistics. We will understand this topic in the next class. If you like the video, please do like, share, subscribe and comment below. Thanks for your attention and time. Happy learning.